So problem 5a is a regex problem, and essentially we're trying to see which of the following strings can be entirely matched by the regular expression below, and we just have to check all of that apply. So for these types of questions, my strategy is first to kind of convert the regex expression into something more similar to English that we can kind of understand. So in order to do this, let's first break up based on like the different types of options we have. So for example, we have one option here and then another option here because these two options are separated by this or statement right here. So essentially what it's saying is you can either choose to match with the left side or you can choose to match with the right side. So now what is the right side saying, for example? So the right side is saying that we can choose either a C or a S. We can choose one or more of them. So one or more C's and S's. And then we have a 6. And then we have one or more 1s. Okay. So just to make it clear, these are the actual values that we have to include. The other numbers represent just how many of them we could have. So that's option 2. Now option 1, the stuff on the left of the or sign, is a little bit more complicated, but we can break this down. So essentially what the CS means, you can either choose a C or S, so one C or S, and then you have 1, 6 or 1, and then you have a or, so all of that's an or you can have A, B, or C. A, B, C. And all of this is optional. And finally, after that optional kind of expression, you can just have C and then S and as many S's as you want, right? So like dot, dot, dot. Okay, so the stuff on the left is a little bit more messy, but hopefully this will just kind of give us a nice framework for when we're analyzing each individual option to see if we can match it with either the left side or the right side. Oh, actually, I'm noticing a mistake here. So I've noticed that this CS is within parentheses, which means that the plus applies to everything in the parentheses. So instead of being CS and then as many as you want, it's really going to be CS and then CS and then CS. And you have as many of those CS pairs as you want. Okay, cool. Now with that out of the way, let's dive into our first option, I guess. So since we already established that the right side is a lot easier to kind of analyze and understand, let's just see to start off with if CS61A can be matched using the right side. So notice that CS61A ends with an A, and on the right side, we don't have an A at all. So you know automatically that there's no way to match CS61A with the right side of the OR. So that leaves the left side on the OR. Well, here we have A's, right? We have an option to add A's, but the problem is the last thing that you must add has to be a CS, right? It can be 1 CS, 2 CS, as many CS's as you want, but the point is it has to be a CS. And since CS61A doesn't end with a CS, it ends with an A, we know that this is not going to be a valid option. So I'll just mark in red. This is not going to be valid. Okay, so for the next option, again, we're going to follow the same strategy of first analyzing if it can be matched with the option on the right, and then if it can be matched with the option on the left, because the option on the right is just simpler. So immediately we know that it cannot be matched with the option on the right because the right side requires you to end with a 1, whereas this problem ends with a CS, right? So immediately we know it can't be matched with the option on the right. Now let's look on the left. Well, this seems kind of promising, right? Because it ends with 2 CS's, which we can match using this block right here. So let's just kind of match that and ignore ignore these 2 CS's and see if we can match now the rest of the string using this argument. because we've used the CS pluses for the right side that we just crossed out. Okay, so CS61A, can we match it with just this stuff inside the question mark? So let's see. Well, for sure, that's going to be a no. Just because the maximum number of letters you can get with this, or like characters you can get with this like expression here, is going to be 2. Because you can either choose a C or a S, so let's say we choose a C, then you can either choose a 6 or a 1, let's choose a 6, or you can choose a value among A, B, and C. So like, or you can choose like A. But in no, like we don't have the ability to choose multiple of each of these options. So in reality, in order to match this, we would need to choose both a C and a S, a 6 and a 1, and then also an A. But we're only given the option of choosing either one, right? So this is going to be also a no. Cool. All right, so the third option, again, looking at the stuff on the right of the OR, it seems like we can match this. So, and I'll tell you the way you match it. Well, it says right here that you can choose as many C's or S's as you want, as long as you have at least one. So let's just choose one C and one S, right? And then we are allowed to choose a 6, or we have to choose a 6, and then we're allowed one or more 1s. So let's just choose 1, 1, and then we get CS61. So this is going to be matched using the stuff on the right of our OR. Cool. Now let's look at the next option, so CSCS. We know we can't match this anymore with the right side of our OR because, again, the right side has to end with a 1, and here we're ending with a CS. But it seems like you can match it with the left side of the OR because remember, this entire expression is optional. So if we simply choose not to include that optional argument, we're left with CS plus. So we can have at least one CS, which is exactly what we have here. We have 2 CSs, so that's perfectly valid. Cool. Now the next option, again, looking at the right-hand side, well, this is pretty promising again because it ends with the 1, which is what we require. And it looks like we can match this by using, since we're allowed to choose one or more C's and S's, so let's choose 1 C, 1 S, 1 C, 1 S, and then we have to choose a 6, so get a 6, and then we're allowed to choose one or more 1s, so let's choose 2 1s. And that's the string we're trying to match. So yes, we can match it with this. So you can have a similar argument for the next problem because of this key thing, which just lets us choose as many C's and S's in whatever order we want. So let's choose 3 C's and then 3 S's, and then a 6 is guaranteed that we need to have a 6, and then we can have one or more 1s. Let's just choose to have 1 1, and then we have the string. Cool. So the next problem, it's tempting to think that we can match it with the right hand side, but we can't because we're only allowed to have 1 6. So we have to have 1 and only 1 6, whereas in this pattern, they're asking for 2 6s. So we can't match it with the right hand side. Now let's look on the left hand side. Well, this also cannot work because we know that the right hand side, or sorry, the left hand side has to end with a CS. And here we end with a 6 1, so immediately we can't match it with the right hand. We can't match it with the right hand side. We can't match it with the left hand side. So that means we can't match it at all. Boom. Okay. Last problem. Immediately we can't match it with the right hand side because it doesn't end with a 1. So looking on the left hand side, we have an S, which means so let's just see if we can match this. So we end with a CS, which is good because that's what we require. And then we have S1 left to match. Well, let's see if we can match it using this optional argument. So we can choose we can choose an S between C and S, and then we can choose a 1 between 6 and 1. And then we have that OR, so if we're choosing to use the left side of the OR, which is probably what we're going to do because we matched it perfectly, then we can ignore the stuff on the right side of the OR. So that means we're essentially just choosing 1 S, 1 1, and then a CS, and we get S1 CS, which is what we want. So these should be the matches you get for this problem.